Next topic is 1.8 in our reduced syllabus, dimension of physical quantity, which is the one of the most important and interesting questions of chapter number 1. So let's start. What is dimension? First I will write the definition. What is dimension? डायमेंशन की डेफिनेशन लिखती हूँ. Each basic physical quantity, measurable physical quantity, measurable physical quantity. All kinds of quantity are measured. Physical quantity represent what it represent. It represented by the specific symbol like लेंथ का कैपिटल L, मास का कैपिटल M. Specific symbol with square bracket, symbol with square bracket is called dimension of physical quantity. Of physical quantity. Or dimension of physical quantity. Like dimension of length, breadth, radius, distance, displacement, are measured in meter. So they all have the same dimension. Are measured in meter. So they have same dimension, capital L, same dimension, which is capital L. Here I will write the significance of dimension, significance or importance. Dimension depends upon the physical nature of dimension. Depends on physical nature of quantity. Physical nature of quantity. Now we will take some examples and then I will write the advantages and limitation of dimension. For example, dimension of velocity, dimension of velocity is equal to distance over time. Distance is a base quantity. Velocity is the distance over time. So distance is measured in L, and time is capital T. So it will become V is equal to LT minus 1. A is power 1. When it will move upwards, it will be minus 1. Dimension of velocity is LT minus 1. Now we will take acceleration. Acceleration is change in velocity over time. So velocity we have find here LT minus 1, T dimension, it will go up minus 1, minus 1, minus 1 would be minus 2. So acceleration's dimension is LT minus 2. Then force dimension would be F is equal to MA. M is mass, capital M, and acceleration we have find LT minus 2. Now we will simply put them in one bracket, so it would be M L T minus 2. So these are the examples of dimension. Now we will write we will do advantages and limitation of dimension. Now we will discuss application of dimension. You can say it advantages, benefits, whatever you want to say it. So there are 3 applications. Number 1, homogeneity of equation. Number 2 is derivation or derive the formula. Derivation of relation भी बोल सकते हैं, derivation of relation. And number 3 is dimension of constant. So there are 3 applications: homogeneity of equation, derivation of relation, dimension of constant. So first we will do homogeneity of equation. What is homogeneity of equation? If dimension of left hand side and right hand side are same, dimension of left hand side and right hand side are same, then this is called principle of homogeneity. then this is called principle of homogeneity. It may be or may not be correct. With help of dimensional analysis, we can check the homogeneity of equation. Now, if we take some example to understand it more clearly, for example, if we take the second law of motion, S is equal to VI t plus half AT square. So first we have to take the left hand side. Solving this, left hand side is distance and distance is the length, so its dimension would be capital L. And right hand side, VI right hand side is VI t plus half AT square. So velocity is L t minus 1 into time plus half. Acceleration is L t minus 2 and time is t square. So minus 1 plus 1 minus 1 plus 1 are cancelled, and here minus 2 and plus 2 are cancelled. We are left with L plus 1 over 2. Here is also L. So by taking the LCM 1 plus 1 over 2, here would be 3 over 2 plus 1, 3 over 2. So the dimension would be 3 over 2 into L. See, the dimension of left hand side and right hand side, they are equal, so it is proof. Left hand side is equal to right hand side, so proof. Second is derivation of relation. With the help of bi-dimension analysis, This is we can derive formulas. We can derive formulas like the formula of, for example, we derive the formula of time period. T is equal to 2 pi under root L over G. Now I am doing the solution of this to derive the time period of simple pendulum. So T is directly proportional to M L G is directly proportional to MLG. T is equal to, now removing the constant, removing the proportionality sign, we get T is equal to K M L G. Now if we suppose put the coefficients here, A, B and C, naming that equation number 1. Now putting the dimension of mass, length and G. So T is equal to K as it is, M to the power A, L to the power B and G is acceleration LT minus 2 to the power C. Now comparing the coefficients, we get coefficient here is in the left hand side there is no in the left hand side there is no mass, so here would be M0 is equal to MA. Then L, in the left hand side there is no L, then it will be 0, M plus C. Here is L, C multiplied by 1 plus C. Then we will compare the coefficient of T to the power 1 is equal to T to the power 2 minus 2C. Now we are comparing the coefficient. Here A would be 0. Here B plus C is equal to 0. Here 1 is equal to minus 2C. C is equal to minus 1 over 2. Put this minus 1 over 2 in this equation. B plus minus 1 over 2. Plus minus minus. Here it is minus. When it will come here, it will be plus. So B is equal to plus 1 over 3. Putting these values in equation number 1, so we get T is equal to K, M is A to the power 0 and L is LB plus 1 over 2 and G is minus 1 over 2. So this is no more here because it is to the power 0, and under root is equal to 1 over 2, and this g would be in the denominator as it is with the power minus. So t is equal to k under root L over g. Here k is a constant, its value is 2 pi. K is constant, its value is 2 pi. So t is equal to 2 pi under root L over g. We proved that. Proved. Number 3 application is dimension of constant. So with the help of dimension analysis, with help of dimensional, we can find the analysis. We can find the dimension of constant. I will give you example for it. Dimension of constant. For example, if we take the energy of photon equation, E is equal to hf, where h is the Planck constant and f is the frequency. We have to find this h constant value. H we have to find it. H would be equal to E divided by f. E is the energy of photon and f is the frequency, and E is the energy of photon and h is the Planck's constant. Okay, so first we have to find a dimension of E. E is equal to work done, or you can take the formula of kinetic energy or potential energy. So I am taking here work done. E is equal to work done. Work done is equal to force into displacement. Dimension of force is ml t minus 2 multiply by displacement is length is taken as L. So this will multiply with this. So this will be ml square t minus 2. Now frequency is the reciprocal of time period. So it will be t minus 1. When this will go up, it would be minus 1. So putting these values in equation 1, name this equation as 1. So putting these E value, energy of photon and frequency in equation number 1. So H would be m L square t minus 2 divided by t minus 1. So the value of H would be this t would go up and would become plus 2 plus 1, minus 2 plus 1 would be minus 1. So we get the dimension ml2t minus 1. Now we will discuss the limitation of dimensional analysis. First limitation is we cannot derive relation relations other than power of friction of power of other than product of power function like S is equal to VIT plus half AT square, or V is equal to V naught cos omega t. We cannot derive it directly. We have to use the left hand side, and then first we have to solve left hand side, then right hand side. If they both are equal, then the equation is dimensionally correct. If not, they are not correct dimensionally. So first limitation is this, and second limitation would be if we are having three physical quantities out of three, it is out of three, two are of same dimension. Out of three, two are of same dimension, out of which two are of same dimension, so dimensional analysis is not possible. Analysis is impossible. Third point is numerical constant, trigonometric ratio, ratios and ratios are impossible, not possible. And fourth and the last point is and the fourth point is more than three unknown. If there is more than three unknown, we can check the unknown. We can check the correctness of equation. But if there are four unknowns, we cannot check. So these are the limitation of dimensional analysis. I hope you liked this video. Thank you for watching. Allah Hafiz.